This is homework number 8. We're going to solve problem 9. And this is part 2. I did a preview of this problem in the previous video, so now we're actually going to solve it. Alright, in order to solve this exponential equation, where e is the base in our function, in our equation, I want to get e and its exponent by itself, because the value I'm trying to solve for, t, is buried in the exponent. So actually I want to get t by itself eventually, but first I have to get e alone. And there's a 1000 stuck on e, and it's stuck there with multiplication. So to get it off, I need to divide both sides of my equation by 1000. Again, I'm trying to get e alone first, and then I'll be able to get t alone to solve for it. So this gets rid of our 1000 on e, because that makes 1, and I get e to the 9/100ths times t is equal to 5 on the right side, 5,000 divided by 1,000. Now, in the preliminary video, I showed you that the ln of e is 1. In other words, when you take the ln of an exponential function, or an exponential base, you get 1. It undoes itself. So I'm going to take the ln of both sides here. I'm going to take the ln of e to the 9/100ths t, and whatever to do to one side of an equation, I need to do to the other side also. So I'm going to take the ln of 5. So this is an operation that I'm performing on both sides of the equation, which is legal. It's going to keep the equation equal. Well, this is just going to make 1. And I'm going to just get 9/100ths t. It's going to undo this, so my exponent actually falls on the ground and comes out of this equation. And on the other side, I've got the ln of 5. So this undoes this, and I get my t almost alone. I still have it times by 0.09. Now again, I want to get t alone, so I'm going to get rid of the 9/100ths that's multiplied by it by dividing both sides by 9/100ths. And this will get my t alone here. And now on my calculator, I can do the ln of 5 divided by 9/100ths, because I have an ln key. And my calculator can do this. So ln of 5, close those parentheses, divided by 9/100ths, and I get approximately 17.883. 17 and 883 1,000ths. And it looks like we are rounding to the nearest thousandth, so I guess that's how I'm going to leave my answer. So that means that if I put this value back in my original equation and do 1,000 times e to that number, when I multiply it by 9/100ths, I'll actually get 5,000. Again, you can check these. You can actually put the number you got in for t and raise this base to that power, and it should equal 5,000.